All right, so as we were discussing, so now we already understood a little bit on communication system, transmitter, receiver, channel, noise. So now we talk about modulation and multiplexing, two of techniques we use in almost all communication systems. Modulation and multiplexing are electronic techniques for transmitting information efficiently from one place to another. So modulation makes the information signal more compatible with the medium. Multiplexing allows more than one user or signal to be transferred simultaneously over a single medium. So means modulation is making the signal to be suitable for transmission or suitable for the media. Multiplexing means we put more number of users or channels in a single physical channel. So I will explain a little bit more after this. We have baseband transmission. Baseband information can be sent directly and unmodifiedly. So means when we talk about baseband means signals which are not modulated. So it's the original form. For example, my voice is sending from a channel free space coming to until to the microphone is baseband because there is no any modulation happen. From the microphone which become electrical signal is also considered as a baseband until it goes somewhere which going to be transmitted or converted to another form. So it happened in many, some cases, like for example, in your computer data, inside the computer, they're sending signals from one party to another or another one device to another device inside your computer. They don't do any modulation. They are just sending the binary data in the original format. So they are referred to the baseband. So in fact, baseband means unmodulated signal. In many telephony communication, when you talk about, when you talk from your fixed line telephone until a little bit distance from your home to an exchange switch, there are still some baseband communication. Means your voice is just sent as electrical signal a little bit distance, maybe tens of meters or hundreds of meters. Then from there, it will be, modified or manipulated with modulation system or multiplexing. So that signal, which is a still original form and not modulated, converted to higher frequency, we call it baseband. So the telephone or intercom systems, the voice is placed on the wires and transmitters. So this is basebands. in some computer networks, the digital signals are applied directly to coaxial or twisted pair cables for transmission. So we don't do any modulation. If they are short distance and they are not going to be shared the channel with another user. For example, when you talk from your phone, it goes a little bit far from your apartment, maybe down somewhere, is only one cable, which you are utilizing that channel fully. No other neighbors using that. So that is where the baseband can be transmitted. But if two people want to use one channel, you can't send by baseband because they will be mixed, because both of you are using same frequencies, unless there are some device to produce a multiplexing or some, then it become no more baseband. So that is what is baseband. So broadband, or sometimes we also talk about passband. Broadband also can be referred to passband. So broadband transmission is a carrier with higher frequency is involved. So which do the modulation. So can be audio, video, or data. So a radio frequency or wave is an electromagnetic signal that is able to travel long distances through space. So now there are some very fundamental questions to understand. Is modulation or converting our baseband signals to high frequency, is this something necessary to be transmitted? Why I don't use the baseband signal to just transmit? What are the issues or limitation, and why? What are the reasons to produce or convert the low frequency signals usually to very high frequency signal before transmit? In fact, we are not very interested to use high frequencies. The reason is high frequencies will be lost faster. We would like, ideally, use low frequencies because they can travel longer distance. But there are some technical issues. We cannot send low frequencies. So yeah, that is what I want to know. If we use high frequencies, which we are doing, we know the loss will be more, but there is no other option. If we use low frequencies, we have some other limitations, which is even worse than loss. The loss we can solve, we can put amplifiers. But there are other technical issues. We cannot send low frequencies. If we have only one low frequencies, it's fine. But still there are some other limitations which we need to convert them to higher frequencies or modulate them. So if someone can explain those, what are those limitations? Okay, one issue is let's talk about only one signal. If you want to send a message by an antenna, so, and the other party also need to receive this, they need an antenna to receive them. Let's talk about radio frequency. You know, if you want to receive a signal with an antenna, the size of antenna should be, based on the wavelengths. I haven't yet explained what is wavelength and what is frequency. Frequency means the signal cycles over a period of time. So you have 1 kilohertz, 2 kilohertz, 1 hertz. Our voice is usually in the range of 300 to 3 kilohertz. Let's say if you want to send such voice somewhere, and assuming our voice power is enough to travel to a distance from the other side, if they want to receive this, they need an antenna to receive this electromagnetic wave. Then that antenna receives the electromagnetic wave as electrical signal come to be converted to voice. Your antenna should follow the wavelength, and the wavelength of lower frequencies have longer wavelengths. So soon after this, we will see the lower frequencies, the longer wavelengths. If you want to have an antenna for voice, I guess the antenna should be in the range of maybe kilometers, which is not practical. So that's why for you to make the size of antenna smaller, you need to increase the frequency higher and higher. So then from one side, your transmission antenna is smaller. From the other side, the receiver antenna also is smaller. So that is one technical problem, which the size of antenna follows the wavelength. So to have a smaller antenna, you need a smaller wavelength. A smaller wavelength means higher frequencies. So that's why most of radio frequencies are in the range of mega or gigahertz. So that is one reason. So there are other reasons which I want to open again the floor for you guys if you can comment. What is other reasons we go to higher frequencies? When we do modulation, then we have higher frequency. So then we are able to do multiplexing. What John said, we can share one channel with multiple, users to share. So if we want to use, for example, our voice, our voice, all of them are the same frequency. If we send from one channel, they just mix to each other. At the receiver, you cannot filter them because all of them are from 300 to 3 kilohertz. If you want to filter my voice with John's voice with another person's voice, is almost impossible because they are all in the same frequencies. What modulation help us to do is, when we modulate the signals, my voice will be modulated with one frequency, let's say 1 megahertz, just as example. John voice will be modulated with another frequency, 1.1 gigahertz, megahertz. Another voice, someone else, will be 1.2 megahertz. Each of them separated by some frequency range. At the receiver, we put filter. 1 megahertz for me, 1.1 for John, 1.2 for someone else. That is allowing us to do the multiplexing. And this is what I am explaining is in fact frequency division multiplexing. If we don't do modulation, we are not able to do the multiplexing then. So that is one of another reason why we want to do modulation. There are other type of multiplexing as well, like time division. If we want to use same frequency, we may use time division, but when we want to transmit the signal, we still need, talking about again the antenna, is multiplexing is not the main reason because there are, as I said, other multiplexing technique like time division. But the main reason to do modulation is the limitation of antenna, transmitter and receivers. So that is the main reason why we need a modulation. The next is we can use frequencies to do multiplexing. So, in fact, when we talk about digital signals, means if our baseband signal is digital and we modulate them using frequency, it becomes frequency shift keying. Means frequency shift keying mainly refers to digital signals, while frequency modulation refers to analog signals. If you see here, these are sine wave. If you refer to here, you have, digital signal, and we use frequency for modulating digital signal. We call it frequency shift keying or FSK. So that's the difference. Okay. Or phase shift keying for instead of frequency modulation, phase modulation for analog signal, for digital signal, we call it phase shift keying. Same for frequency shift keying. Yes, exactly. This is phase shift keying. You can see there is a phase difference while the frequency looks all remain the same across, and the level also is the same. So is a phase shift keying. So when we do this, the signal is no more baseband, it become band pass. So then we send this to the channel, and then we do demodulation, and then we do digital to analog conversion. It comes to the user. So that is just example of how different types of modulation could be used for the same signal. So, okay, this I have already mentioned. I should shift this to few slides earlier. Okay, next is multiplexing. Multiplexing is not modulation. Multiplexing is just talking about putting few channels, few users in one channel. It's talking about sharing the channel. One channel means maybe one wire or maybe one frequency band. We call it as a channel. So when we do multiplexing, we may put few users in one of these channels. There are different types of multiplexing. The common one are frequency division, time division, or code division. There are many more, and we have wavelength division multiplexing. We have polarization division multiplexing, which is related to optical. We have many of phase division multiplexing, combination of phase and amplitude. We have like QPSK, quadrature, phase, shift keying. Many of them goes for digital communication, and so there are quite a number of those. But in this course, we mainly talk about frequency and time and maybe wavelength. Okay, here shows a schematic for multiplexing. We have multiple baseband signals, baseband like our voice. Let's say we have few voices. Let's say I am living in this apartment. So there might be many users at the same time use their telephone. Our telephone wires maybe goes to maybe somewhere in the apartment, for example, just as example. There we may have a time division multiplexing, for example. Use one wire to send our signal to combine them in terms of time. So then do a modulation with a carrier sent to antenna or something directly from maybe a cable to a little bit further to telecom station. Maybe that could be one multiplexing, which is doing in the baseband level. So then the demultiplexing doing opposite. Later, when it going to the receiver side, they will distribute back their signal from that time to the related users. And then they will receive their own signal. So that is what multiplexing do in general. If I show you a little bit more on time division, which we will have again later in detail. So for example, my here is showing a computer, for example. There are 3 computers of A, B, C. Each computer sending maybe a packet, or you can consider a packet which consists of a certain number of bits or binary bits like 0101, or you may consider one bit itself to say, okay, A1 is 1 bit, either 0 or 1. So is more meaningful, we refer to a packet, so few bits maybe. So what a multiplexer does, let's say this is time, as we said. So it takes a little bit from first channel, then take a little bit from second channel, and then take a little bit on third channel. So is in terms of timing. So what happened is the first channel, the first user, they take their data, then the second one and the third one. Something very important you should understand. A1 may have, let's say 1 second duration. What multiplexer does in taking portion of A1, not the whole 1 second, because otherwise if 1 second A, B, C produce, each of them is 1 second, the multiplexer only takes 1/3 of a second. Take samples from this, represent here as A1. B1 takes samples for 1/3 of 1 second to put for B1, and take 1/3 of from the third channel, put here, and then transmit. So if they want to take the whole thing, of course, there is no enough time. So if I show you by a signal, let's say if there is one signal, 1 second duration, representing bit 1, multiplexer only takes sample for maybe 1/3 of 1 second, and go to the second channel, another 1/3 of channel, the signal. For the third one, also 1/3 of time take sampling. So means the 3 channels all together become 1 second. Then they go. They cannot get the whole 1 second. The rest will be just ignored. So then it goes to the second bit or second frame or second signal. Take again. So what the 3 channels do, they sharing the communication channel by time. So they may continuously produce signal, but the multiplexer only take 1/3 to fill the channels. We call it synchronous time division multiplexing. This is asynchronous or a statistical time division multiplexing. So is another type. So here they goes, the frame types could be different. So here, each user may have some additional information for per bit or per frame. So later we may come back to this and learn more about this. This is another multiplexing is frequency based. The first, second, and third, all of them are like voice. They have same frequency. You cannot combine them because if you combine them, they will be lost. You cannot separate them anymore. What we do is the first signal, we use first carrier with one frequency, a little bit lower frequency, second user for a little bit higher frequency, third user with a little bit higher frequency. We do here, they do amplitude, amplitude modulation is frequency multiplexing, but amplitude modulation. And then they combine together, send to channel or antenna. At the receiver, we use filters to separate different frequencies, and then we demodulate to get the signal. So that is multiplexing with frequency multiplexing and amplitude modulation. Okay, so we stop at this slide, which is electromagnetic spectrum.